Welcome. Today we're diving into the fascinating world of debugging in computers. Debugging is a crucial process in software development, helping programmers identify and fix errors in their code. Whether you're a beginner or an experienced developer, understanding debugging is essential for creating reliable and efficient programs. In this video, we'll explore what debugging means, why it matters, and how it fits into the broader context of computer science. Let's start by defining what debugging actually is and why it's such an important skill for anyone working with computers. Bugging is the process of finding and resolving defects or problems within a computer program. When a program doesn't work as expected, developers use debugging techniques to locate the source of the issue. This might involve checking the code line by line, using special tools, or even discussing the problem with teammates. Debugging isn't just about fixing mistakes, it's about understanding how and why errors occur, which leads to better programming practices overall. The term debugging has an interesting history. It dates back to the early days of computing when engineers literally found bugs like moths causing problems in hardware. Today, the term refers to removing logical or syntactical errors from software. This historical context reminds us that debugging is a fundamental part of working with computers, whether we're dealing with physical machines or lines of code. Bugging is essential because even the best programmers make mistakes. Without debugging, software would be full of errors, leading to crashes, security vulnerabilities, and poor user experiences. By systematically finding and fixing issues, developers ensure their programs run smoothly and reliably. Debugging also helps improve the overall quality of software, making it safer and more enjoyable for users. Not all bugs are created equal. Some are simple typos, while others are complex logic errors that are hard to spot. Bugs can be syntax errors, runtime errors, or logical errors. Syntax errors occur when the code doesn't follow the rules of the programming language. Runtime errors happen when the program is running, and logical errors are mistakes in the program's logic. Understanding these types helps developers approach debugging more effectively. Developers use a variety of tools to help with debugging. Integrated development environments, IDEs, often come with built-in debuggers that allow programmers to set breakpoints, inspect variables, and step through code. There are also standalone debugging tools and plugins that provide advanced features. These tools make it easier to find and fix errors, saving time and reducing frustration. Breakpoint is a marker that developers set in their code to pause program execution at a specific point. This allows them to examine the state of the program, check variable values, and understand what's happening at that moment. Breakpoints are incredibly useful for isolating the exact location of a bug, making the debugging process more efficient and targeted. Stepping through code means executing your program one line at a time. This technique helps developers see exactly how their code is running and where things might be going wrong. By stepping through, you can watch the flow of execution and catch errors that might be missed when running the program all at once. Inspecting variables is a key part of debugging. By checking the values of variables at different points in your program, you can see if they're behaving as expected. If a variable has an unexpected value, it can point you directly to the source of a bug. Most debugging tools make it easy to view and modify variable values during execution. Error messages are often the first clue that something is wrong in your program. They provide information about what went wrong and where. Learning to read and interpret error messages is a vital skill for any programmer. Sometimes, the message is clear and points directly to the problem, other times it requires deeper investigation. There are many strategies for debugging, and the best approach often depends on the situation. Some developers start by isolating the problem area, while others use systematic testing or divide the code into smaller parts. The key is to stay organized and methodical, testing one change at a time to see its effect. Rubber duck debugging is a fun and surprisingly effective technique. It involves explaining your code line by line to an inanimate object, like a rubber duck. By verbalizing your thought process, you often spot errors or gaps in logic that you might otherwise miss. This method highlights the importance of clear thinking and communication in debugging. Sometimes, debugging is best done with others. Pair programming and code reviews allow developers to spot errors that one person might overlook. Collaboration brings fresh perspectives and can lead to faster, more effective problem solving. It's a reminder that debugging isn't just a solo activity, it's often a team effort. Automated debugging tools can scan your code for common errors and suggest fixes. These tools use algorithms to detect patterns that often lead to bugs. While they can't catch every issue, they're a valuable first line of defense, especially for large projects with thousands of lines of code. Logging involves adding statements to your code that record information about program execution. These logs can help you trace the flow of your program and identify where things go wrong. Effective logging is a powerful tool for debugging, especially in complex systems where issues may not be immediately visible. Testing and debugging go hand in hand. Writing tests for your code helps catch bugs early, making the debugging process easier. Unit tests, integration tests, and system tests all play a role in ensuring your program works as intended. When a test fails, it's a signal that something needs to be debugged. Debugging techniques can vary depending on the programming language you're using. Some languages have robust debugging tools while others require more manual effort. Regardless of the language, the core principles of debugging, finding, understanding, and fixing errors, remain the same. Web developers often use browser-based debugging tools to inspect HTML, CSS, and JavaScript. These tools allow you to see how your website is rendered and interact with the code in real time. Debugging web applications requires a good understanding of both client-side and server-side issues. Debugging mobile applications presents unique challenges. Developers use emulators, simulators, and device logs to track down issues. Mobile debugging often involves dealing with different operating systems, screen sizes, and hardware capabilities, making it a complex but rewarding process. Embedded systems, like those in cars or appliances, require specialized debugging techniques. Developers use hardware debuggers and serial output to monitor system behavior. Debugging embedded systems often means working with limited resources and real-time constraints, adding extra complexity to the process. Debugging isn't just about fixing functional errors, it's also crucial for security. Bugs can create vulnerabilities that hackers exploit. By thoroughly debugging code, developers can close security gaps and protect users from potential threats. Security-focused debugging is an important part of modern software development. Sometimes, programs work correctly but run slowly or use too many resources. Debugging performance issues involves profiling your code to find bottlenecks and optimize efficiency. Tools like profilers and analyzers help developers understand where time and resources are being spent, leading to faster, more efficient software. Memory leaks occur when a program doesn't release memory it no longer needs. Over time, this can cause the program to slow down or crash. Debugging memory leaks involves using specialized tools to track memory usage and identify where leaks are happening. Fixing these issues is vital for long-running applications. Multithreaded programs can be especially tricky to debug. Issues like race conditions and deadlocks are hard to reproduce and diagnose. Developers use thread analyzers and synchronization tools to find and fix these complex bugs, ensuring that programs run smoothly even when multiple tasks happen at once. Remote debugging allows developers to debug programs running on a different machine or environment. This is especially useful for cloud-based applications or systems that can't be accessed directly. Remote debugging tools connect to the target system, providing the same features as local debugging. Open-source projects often have large, distributed teams. Debugging in these environments requires clear communication and thorough documentation. Contributors rely on issue trackers and version control systems to report, discuss, and fix bugs collaboratively, ensuring the project remains stable and reliable. Agile development emphasizes quick iterations and continuous improvement. Debugging is integrated into the workflow with frequent testing and feedback loops. This approach helps catch bugs early and ensures that software evolves smoothly over time, adapting to changing requirements. Working with legacy code, older software that may not be well documented, presents unique challenges. Debugging legacy systems often involves reverse engineering, careful testing, and sometimes updating outdated code. Patience and attention to detail are key when dealing with these complex systems. Good documentation makes debugging much easier. Clear comments, well-written manuals, and up-to-date diagrams help developers understand how a program works. When issues arise, documentation provides valuable context, speeding up the debugging process and reducing frustration. Continuous integration (CI) systems automatically build and test code whenever changes are made. This helps catch bugs early before they reach production. Debugging in a CI environment involves analyzing build logs and test results to quickly identify and fix issues. Version control systems like Git help track changes in code, making it easier to identify when and where bugs were introduced. By reviewing commit histories and using features like blame, developers can pinpoint the source of issues and roll back problematic changes if necessary. High-quality code is easier to debug. Following best practices like writing clean, modular, and well-documented code reduces the likelihood of bugs and makes them easier to find and fix. Investing in code quality pays off in the long run by simplifying maintenance and debugging. Debugging is a powerful learning tool. By investigating and fixing errors, developers deepen their understanding of programming concepts and languages. Each bug is an opportunity to learn something new, making debugging an essential part of the educational journey for programmers. Debugging isn't just a technical skill, it's also creative. Finding solutions to tricky bugs often requires thinking outside the box and experimenting with different approaches. Creative problem-solving is at the heart of effective debugging, making it both challenging and rewarding. Debugging can be frustrating, especially when bugs are hard to find. Patience and persistence are essential qualities for successful debugging. Taking breaks, staying calm, and approaching problems methodically can make the process more manageable and less stressful. Effective communication is vital in debugging, especially in team environments. Clearly describing problems, sharing findings, and documenting solutions help everyone stay on the same page. Good communication speeds up the debugging process and leads to better outcomes. Debugging can take a lot of time, so managing your time effectively is important. Setting clear goals, prioritizing tasks, and knowing when to ask for help can make debugging more efficient. Balancing debugging with other responsibilities ensures steady progress on your projects. Debugging can sometimes be stressful, especially when deadlines are tight or bugs are elusive. It's important to manage stress by taking breaks, practicing relaxation techniques, and maintaining a healthy work-life balance. A clear mind leads to better problem-solving and more effective debugging. Mastering debugging is a key part of professional growth for programmers. It builds confidence, sharpens problem-solving skills, and prepares you for more complex challenges. As you gain experience, you'll develop your own debugging strategies and become a more effective developer. Many industries have standards and best practices for debugging. Following these guidelines ensures consistency, safety, and quality across projects. Adhering to industry standards also makes it easier to collaborate with others and maintain code over time. Debugging drives innovation by encouraging developers to experiment and try new solutions. When faced with challenging bugs, creative thinking can lead to breakthroughs and improvements in software design. Embracing the debugging process fosters a culture of innovation and continuous learning. User feedback is a valuable source of information for debugging. Users often encounter issues that developers might miss during testing. By listening to feedback and investigating reported problems, developers can improve their software and provide a better experience for everyone. As technology evolves, so do debugging techniques. New tools and approaches are constantly being developed to handle emerging challenges such as artificial intelligence and quantum computing. Staying up to date with the latest trends ensures that developers are prepared for the future of debugging. Sum up, debugging is a vital part of computer programming. It involves finding, understanding, and fixing errors to ensure software runs smoothly and securely. From basic techniques to advanced tools, debugging is a skill that every developer needs. Embracing the process leads to better code, happier users, and continuous personal and professional growth. Thank you for joining us on this journey through the concept of debugging in computers. Whether you're just starting out or looking to refine your skills, remember that debugging is a continuous learning process. Stay curious, keep practicing, and don't be afraid to tackle new challenges. With patience and persistence, you'll become a more confident and capable programmer.